Hello guys, this is CodeNCode and this is video editorial for the problem Codeforces Subsequence taken from Global Round 8, and this was B problem from the Round 8. So yep, the problem is we are given an integer k and we have to print a string with minimum number of characters such that it contains at least k subsequences, which is equals to code forces. So for example, this string contains only one subsequence which is equals to code forces, and that is equals to this whole substring, while this subsequence contains this string contains 4 subsequence which is equals to code forces, and the example is shown here like this. The first 10 characters which is equals to code forces, and then instead of having s from here we are using s from here. So you can see code force C, up to CE we are using all of the characters from here, and now for s we are not using this character but this character. So 2 subsequence, similarly 3 and 4. So in this string there are 4 subsequences which are equal to code forces. So we have to print a string which is minimum in length and contains at least k subsequences which are equal to code forces. So this is our task. So if we look two different examples, this is for k is equals to 1. If we want at least one subsequence which is equals to code forces, of course you can print this. For k is equals to 3 you can print this. So you can see you can use code up to this, you can use this substring in all of these 3 subsequences, and then use once use this s, and second time you can use this s, and third time you can use this s. So in total there are 3 subsequences which are equals to code forces, and of course this uses minimum number of characters. We are using only 2 extra characters to make 3 different subsequences. Now the important observation. So our task is to have at least k code forces subsequences using minimum number of characters. So I'll be explaining this with an example. So suppose the example string I'm using is this. So let me show you how many different code forces subsequence I can form using this this string. You can see I'm using 2 C's, 1 O, then 1 D, then 2 E's, then 1 F, O, R, C, E, and 2 S. So basically I'm using 2 C, 2 E, and 2 S, while the rest of the characters are same. So let's see how many code forces subsequence we can form. So see, C is being used 2 times, so I have 2 possibilities to choose C for first C in the code forces. Now for O there is only one possibility, for D there is one possibility, for E there are 2 possibilities to choose from. As you can see there are 2 E's, so for E in code I have 2 choices. So that is why there are 2 choices I can fill E with. Similarly for F, O, R, C, E I have only one choices, because all of these characters F, O, R, C, E are appearing exactly 1 times, while S is appearing 2 times. So the total number of combination that you can form, or basically total number of subsequences you can form which are equal to code forces, are 8. That is 2 times 1 times 1 times 2 times 1 times, and similarly just multiply all of these integers and the total number of combination will be 8. So the total number of code forces subsequences will be 8. So if I show you 1 or 2 examples, choose the first character as first C, and then O, then D, and then to choose E you can either choose from first E or the second E. That is why you have 2 choices. Similarly for F, O, R, C, E, then while choosing S, either you can choose the first one or the second one. So that is why for S we have 2 choices. Now see, for if you want to use like k x number of C's for first C, right? You want to use x number of C's for first C. There are 2 C's, that is why I have to specify first C or the second C. You want to use x number of characters you have x number of characters for the first C in final answer, then you want to make sure that all of the C's are appearing together. So I am using two C's for first C in the Codeforces. So I have placed both of them together. I haven't placed first C here and second C after O and D. If you do that, so when you choose second C as first C in the Codeforces, then you cannot utilize O and D. So it makes sense that if you are using multiple characters for first C, then make sure all of them are appearing together. Similarly for O, you want to make sure if in the final answer you are using 5 O's, then all of those O must appear together, right? So if you are using x1 number of C's, then all of them must come together. All of the x1 characters, x1 appearances of C must come together. Similarly for x2 appearances of O, x3 appearances of D, and so on. So this was one important observation, and using this configuration, these many subsequences we can form. Now using these two important information, we are going to build a solution. Let me show you how. Suppose k was 1050 and we have to find the string which uses minimum number of characters, and of course the total number of subsequences which are equal to Codeforces are at least 1050, right? So when we'll start with all of the characters having at least one appearance, right? Of course, if all of the characters from Codeforces must have at least one appearance, so the total number of subsequence would be 1 times 1 times 1 times dash 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 times 1, which is equals to 1. We can see that total number of subsequence are strictly smaller than k, so we need to increment the characters so the total number of subsequence increment. So how we are going to do that? Of course, I'll be starting from the first C, and it doesn't matter you start from O, D and E, but to make sure that everything is sophisticated, I'll start from the first character. So I have incremented first character, so now I'm using two C's. So total number of subsequences are 2. 2 times 1 times 1 time, basically multiplication of all of the integers you can see. So the total number of subsequences are 2, which is still smaller than k. So what you are going to do increment the next character, which is O. Now the total number of subsequences are 4, which is still strictly smaller than k. Now increment the next character, and that is the total number of subsequences will be 8. Now see, we have used 3 extra characters and now we are able to generate 8 subsequences. Now your question might be, why are we evenly spreading the extra character? Why we are not giving the extra character to only 1 or 2 characters? So see, I have used 3 extra characters and now we are able to generate 8 subsequences. If I have given all 3 extra characters to only 1 character, so basically this would be 4, rest would be 1. So the total number of subsequences would be 4 times 1, which is 4, which is not good, because now we are able to get less number of subsequences which we can achieve while giving while evenly distributing all of the extra characters among the all characters. So if you want to use a minimum number of characters and you want to maximize the total number of subsequence, you have to evenly spread the extra characters among all of the characters. That way the subsequences would increase exponentially. You can see I have used 1 extra character and the sequences became 2. I've used 2 extra character, 1 here and 1 here. So the total number of sequence became 4. I used 3 extra characters, so total number of sequences became 2 raised to power 3. Now I'm going to use 4th extra character and the total number of subsequences are going to be 2 raised to power 4. So you can see, if you are spreading the total number of extra characters evenly, then the total number of subsequences are increasing exponentially. So it only makes sense to distribute the extra used character evenly. That is what we are going to do. So I have incremented this. The total number of subsequences are 16, which is strictly smaller than k. Now we are going to increment the next character. Total number of subsequences are 32. We are going to increment the next character, 64. Again next character, 128. Next character, 256, next character 512, next character 1024, still strictly smaller than k is equals to 1050. So now what we are going to do, of course we will start from first character and keep on incrementing one by one. So first character first character I have incremented, and the total number of combination are 2048, which is greater than equals to k, and we can stop here. Now you see, this configuration will give you 2048 subsequences, which is at least 1050, right? So this is our answer. So this is the configuration. Using minimum number of character, we are able to generate at least 1050 number of subsequences which are equal to code forces. So the answer would be, since we are using three appearances of C, so 3 times C, 2 appearances of O, basically 2 appearances of rest of the characters. So 2 times O, 2 times D, 2 times O, E, F, O, R, and so on. So this would be your answer. I hope you are understanding the fact what we are using here. First, each character what you are using must appear side by side, must appear together, and second, if you are using extra character, you must spread them evenly among the characters so as to maximize the total number of subsequences. That way the subsequences will increment exponentially. So if I show you the code, the code is as easy as the concept. I'm using the integer array. LLI is long int, basically 64-bit integer array of size 11, so that I can have indices from 1 to 10. Now REP is for loop running from 1 to 10. So I am initializing all of the character to be 1. As explained in the slide, each character would be at least 1. There are 10 characters. Index 1 represents C and index 2 represents O, and so on. So we will start where each character is at least 1. Now this is K, reading K, initializing I to be 0. I will act as the pointer to the character which will be incremented next, right? So I have initialized I to be 0, and if k is equals to 1, then you do not have to increment any of the character, because all of the character, if you use 1, so one Codeforces subsequence would be there. So if k is greater than 1, we would do this. What we are doing here, we are incrementing I. So I was initialized with 0, so I would be 1. If I becomes greater than 10, because I'm each time incrementing I, so when I was 10 and you incremented I would be 11. In that case, sorry, that was my alarm. So in that case, of course, you need to reset I to be 1. So this is that condition. So incrementing the ith character and then checking whether the total number of subsequences are greater than equal to k or not. So isValid function will verify that. So what isValid function is doing, from 1 to 10, you have initialized result with 1, and then from 1 to 10 you would multiply all of the numbers to result. Basically you are calculating the total number of subsequences. Initialize result with 1 and just multiply all of the integer with result, so the total number of subsequence result will contain the total number of subsequence. If result is strictly if result is greater than equals to k, then we will return true, indicating that yep, the total number of subsequences now formed are greater than equals to k, and we can stop. If it returns true, we will break, basically stop, otherwise we will continue. So we'll keep doing it until the total number of subsequences are greater than equals to k. Fair enough. Now after that we are simply printing the result. So from 1 to 10, each time if AR of I is x time, we are printing x time the I minus 1th character of string st. And what is string st? String st is Codeforces. So for I is equals to 1, we would be printing I minus 1th character, which will be 0th character, and 0th character will be C, and then O, and then D, E, and so on, right? So this is how you solve this problem. If you have any doubt or query, of course you can ask in the comment section. So thank you guys for watching, and till the next video drops, keep coding.